My name is Rick Seiferth. We're standing on the campus of National Institute of Standards and Technology in the Engineering Mechanics building. I'm standing in front of the largest force standard deadweight machine in the world. It generates 4.45 meganewtons or 1 million pounds of force. The machine is used to calibrate force transducers. A calibrated force transducer might be used to measure rocket engine thrust on a missile. It might be used to measure regular jet engine thrust on a jet engine that powers our airliners. You see the top of the weight stack behind me. The weights themselves are about 3 stories tall, and each weight is about 10 feet in diameter, 3.1 meters. Each weight generates roughly 224,000 newtons of force, about 50,000 pounds force each. That's roughly the size of 10 minivans per stainless steel disc. The machine extends above where I'm standing, roughly 10 stories total in height. Directly above us is the control room or laboratory where the force transducers are actually calibrated. Directly above that is a large hydraulic ram that lifts the entire weight stack. This is the first time the machine has been disassembled since its initial installation in 1965. I think of disassembly as being demolition because in certain ways that's exactly what it appeared to be. Massive air hammer, massive big guys working those air hammers to disengage these very large threaded stainless steel bolts. And likewise, I consider reassembly to be fine manufacturing because that's exactly what it was. While bolts were hammered apart by the big air hammer, they were reassembled by hand. Literally every bolt and every piece went back into this machine by hand for reassembly. I've always known that we deal with national treasures here in terms of national force standards, and indeed because this weight stack is the largest in the world, an international force standard. So the thought of taking a wrench to this weight stack almost seemed sacrilegious. However, we knew it had to be done. First, we had to take the machine apart, and if you can imagine, climbing up at height, being strapped off to a protective beam overhead and handling large wrenches and large impact tools and trying to unloosen large bolts without falling and doing it safely, that's what our guys had to cope with. Next, we had to triage the weights. We assessed the damage, we cleaned up surfaces, literally clean surfaces. Bear in mind, this machine had not been disassembled in 50 years, so some things were dirty. The weights that required remachining were actually taken to machine shops. We literally shaved maybe a millimeter off of these parts. Once those parts came back from the shops, we were able to reassemble those weights because we had to calibrate the weights. Following recalibration of the weight, we were then faced with getting our rigging crew back in here to reassemble the machine. Now the fun began because every step became critical. If we had a bolt misaligned at this point, if we had a part misaligned, if we dinged a thread, consequences would be very severe. When that final bolt went into place, particularly the stainless on stainless assembly, I breathed a sigh of relief because I knew at that point that we had passed a major hurdle. It took a little bit longer to finish this job than I was hoping, but it has been reassembled correctly. I think it's reasonable for us to presume that this will last another 50 years or until primary force standards become passé.